Yes, hello everyone. Uh, Very nice to be here today. My name is Tobias Norlund, and I am. Let me change that. So I am an AI researcher and an engineer, currently working at AI Sweden, and I would like to emphasize that I try to work a bit both on the research side as well as the engineering side of AI and really thrive in the intersection between the two. Basically, work on hard problems that I think is perhaps not solved today, but will make it into the production in, let's say, the coming years or so. And that's also something I would like to talk a bit about today, specifically AI agents, and in particular UI-based AI agents. But before, let's just give a short background on myself. So I've always been very fascinated by AI, and particularly the AI's connection with language. So I think I remember first time I discovered the Wikipedia page for natural language processing, and I kind of knew instantly that this is something I really want to focus my career towards. And I mean, after all, communication and language is also something that sets us humans apart from other species, that makes us be able to transfer knowledge and learn from each other, both across individuals, but also across generations. So I've been researching and developing language models systems actively for the last 5 years, roughly. But I would say also, despite this, I was quite amazed by ChatGPT and GPT-4 when that was released a little bit over a year ago now. So I've always been confident that this technology would eventually take off, but the speed at which it has been developed in the last year or so is just mind-boggling. And now with everything developing so fast, I think at least it gives me some comfort to think about, like, what are the limits of the current technology and where do I think we will be heading, at least in the next couple of years. So what I will talk about today is a bit towards that, what I think are some likely near future scenarios, and what we as developers might expect to work with as well. So some of you might have read this book, Life 3.0 by Max Tegmark, that was released in 2017, I think. So it's almost 7 years now. And in this book, he has this picture of he calls the rising tide of AI capacity, where we have essentially different types of tasks or work of different difficultiness, which is illustrated by the sort of altitude at which they are placed on this map. And then you have the tide, the water level, which is basically illustrating the level at which AI can autonomously do this task right now. So this was Max Tegmark illustration about 7 years ago when it comes to AI capacity. And I think there are there are some things that we might want to change here since then. So for example, programming might not be as high on this map as we would say today. Driving should maybe be a bit higher. Art is also something we made a lot of progress on with generative AI. So yeah, the tide has certainly taken a big leap in the last couple of years, not the least because of developments in generative AI and large language models. But I will also like to focus on what I think will be the next big thing that will make this tide increase to yet another, take yet another large step. And that is agency. So we use large language models today to process knowledge, mainly in text form. And I mean, this is also a centerpiece of what we do as humans, but we are also able to use that to perform work, to take actions, and to get things done. And I think we will see models that go more towards that in the near future. So when we talk about agents, I think it's good to start with trying to sort of define what we actually mean. And an agent is basically a system that takes some kind of state and chooses to perform some kind of action in that state. And it does so within some type of environment. Then when we take an action in the environment, we also end up in a new state, and the agent can choose to do something else. And now optionally, if we also get some kind of reward signal from this environment, we can, for example, apply reinforcement learning to actually sort of optimize the agent's behavior so as to maximize this reward. So some classical agent examples. I think most of us have probably heard and seen this. These are a couple of years old, but DeepMind has been quite successful in this space with, for example, the AlphaGo system, of course. We also had early work on Atari games, where we have an agent that learns to perform, to steer, well, essentially to play the Atari games, to steer the whatever controls you have. So more recently, we have started taking steps towards generality within agent-based systems as well. So more recent work is this Gato system, where we essentially have a single agent system, a single model essentially, that is trained on a lot of different tasks simultaneously. And what they show in this article is also that you can actually boost performance by generality, by training on many different things. And this goes in line with what we've seen in machine learning in general, not the least with large foundation models like language models. So I think a point I want to make here is that by doing this on a general level, we also have to use a common state and action space. So, if we go back to the Atari games, let's say, we might need different types of actions for different games. Or in the AlphaGo system, both the input and the output of the agent is very tailored towards that particular task. But in Gato, we sort of standardize all of that so that it takes essentially tokens as input. The input is tokenized as well as the output. And the whole system is trained in an autoregressive fashion, very similar to a language model. So we can also use LLMs as agents that we've seen, for example, in AutoGPT. So in AutoGPT, we essentially give the system one or a few high-level goals, and we set it off. And now using some previously defined actions that the language model can choose to take, it automatically chooses to perform these actions to pursue this goal. But the important thing I want to highlight here is also that also with language models, we have to do the work beforehand to sort of standardize the actions that are available to this agent. So in this particular example here, the agent is tasked to go out and look out for different brands of headphones, research what the best ones are, what the pros and cons of those are against each other. And to do this, AutoGPT can do a limited set of actions, which are well defined. So in this case, it can choose to do a Google search with some query that the language model generates. It can choose to browse a website with some URL that it may find from Google. It can choose to evaluate some Python code that it writes, and it can also write some results to a file. And these are quite general actions, but still they have to be implemented and integrated by some developer. So if we summarize what we can do with LLMs, both the state and the action are just text. We need to enforce a structured action format somehow. We need to decide what actions are available. And we also need to tell this to the language model. And we can either do fine-tuning or we can do some clever prompting to sort of infuse this information into the model. But importantly, we also actually, for everything that is sort of external to the language model, we also need to develop that integration ourselves. So if we wanted to be able to Google, we need to both define that action, but also actually implement what should happen when that action is triggered. And that's quite some work. So the question I'm asking is, how far will LLM agents actually take us? Because if we are to pursue something called something like AGI, we probably want to have systems that goes beyond what we have and becomes even more general. So I think it's good to, if we are to pursue AGI, I think it's also good to try to define what we're actually talking about. But for me, there's no better sort of impersonation of AGI than the humanoid robot, the general purpose robot that can essentially do anything that a human can. So what is good about the human form factor is that, I mean, we humans have built this world for us. All the tools and infrastructure have been built with us in mind, that we are the users of this. So if we want AI systems to also become more general and be able to perform more and more work without manual tailored integrations, I think AI systems will have to adapt to the interfaces that we humans use to some extent. And the humanoid form factor is perhaps the end state. But I think a question is if we can also make progress towards generality in steps and not aim for the humanoid robot at the first and to do that in one go, so to speak. So I think an autonomous car is a good example of this, which is also an agent. So, for example, in this domain, we recognize that it might be too expensive to sort of rebuild the whole world's road network for self-driving cars. We could imagine putting sensors and stuff on the roads to make it very easy for autonomous cars to drive. But that would be very expensive. So here, at least the Tesla approach is to really adapt the agent to use the human interface essentially the steering wheel, pedals, and in particular the vision-based input to understand where it is and what it should do. So by adapting to the human interface, this also has some other benefits. So for example, it allows for a quite truly seamless co-pilot experience where we can teach the AI agent exactly how we drive by turning the wheel and etc. But we can also intercept quite naturally. So now we can argue the autonomous cars is a good step, and it should certainly be easier than the humanoid robot because the domain of operation is essentially smaller. But also, as it has shown, autonomous cars are quite hard. So even though the domain of operation might be smaller, we only drive on roads essentially. This visual world is also quite broad, and turns out it's very hard to actually capture all the edge cases that might appear on the road. For example, you need to be invariant to illumination. You need to model the behavior of other nearby cars, etc., etc. So all of this also with no tolerance for error, because safety is also such a crucial aspect of this environment. But on the other hand, humanity spends millions of hours driving every day. So if we can actually get this to work, the upside is also massive. So I like to think, what are the sort of prerequisites to build a general AI agent that's also feasible to build in the near future? So when we think about these two examples, of course, we need the work that the agent is doing to be valuable. Otherwise, it doesn't make sense. For the generality aspect, I think it's important that the state and actions imitate the human interface closely, for the reasons I mentioned. For it to be feasible in the near future, the domain of operation should still be somewhat constrained. And if we are to take a foundation model approach to this, as it seems to be the trend right now, there also has to be tons of data, behavior data to learn from. So if we look at the humanoid robot example, the work would certainly be valuable if it can do pretty much anything a human can learn to do. The state and actions imitate the human interface very closely. It's essentially exactly the same form factor. The domain of operation is relatively constrained, so that's where the humanoid robot falls a bit short to be implemented and work well in the near future, perhaps. And perhaps the biggest problem is that there is really no data to learn from. We don't have a massive fleet of robots deployed that collect data. So that makes the humanoid robot less likely, I would argue, to happen in the near future. But what about the self-driving car? So also here, the work performed by the car would be very valuable. We can also adapt to the human interface by using, let's say, vision, and we can also learn from human expert driving by having the same control, steering wheel, etc. The domain of operation is at least more constrained now compared to the humanoid robot, but still turns out to be quite hard to model the world of an autonomous car. And we are now starting to collect more and more data of driving, in particular Tesla. and this is also starting to not become a bigger problem. All right, so that was 2 examples. So I would like to now show what I think is perhaps something that we will see that is even more feasible to show in the immediate future, near future, let's say the coming few years or so. And that is a general computer agent. So essentially what I mean by this is an agent that's able to control a digital device, let's say a computer or a smartphone, using the same interface as humans. So we use the screen to get feedback from the device typically, and we use either mouse or keyboard or touch to interact. So if we look at these prerequisites in this case, how valuable would the work of a general computer agent be? So at least one data point is that the digital knowledge work economy constitutes 15% of the world GDP. So there might not be all of this that is immediately automatable by a computer agent, but it should certainly be a large enough fraction of this. By adapting to the human interface, that would mean we let this agent look at the screen or the graphical user interface of the device, and we let the agent output actions such as mouse or keyboard or touch. By doing this, we would allow the agent to learn to essentially do anything a human can do on a computer. Domain of operation is relatively constrained. Also here, the visual world of a computer is far smaller than that of the autonomous car. Sure, we still have a variety of, let's say, operating systems and types of devices, but in general, a button looks quite similar across these different environments. We typically have windows or icons, etc., that are quite shared. So it should be easier for a model to learn to navigate a graphical user interface than to drive an autonomous car, at least, I would argue. And finally, there should exist tons of data to learn from. So, I mean, humanity spends around 23 billion hours working on a computer every year. And this domain is entirely digital also, so it is easy to simply record a portion of this to train agents on. But since it's also digital, we can actually go quite far in generating this data synthetically. So when it comes to the value, I would say it's a check. When it comes to ability to reuse the human interface, it should be a check. The domain of operation is more constrained than the previous examples, at least. And perhaps when it comes to the data, it's not as readily available as, let's say, text data on the internet. But if one can figure out how to sort of tap into this data stream, I think that's the one that's going to make this a reality. So that's where I would like to present a project of mine that I call UI Act, which is essentially towards a foundation model that I just described, interacting with the computer. So I would like to show you a small demo here where I have a Python script. I'm just gonna start. And let's say that I open a calculator window on this virtual machine here. And I put that window there. So I have now trained an agent here that essentially takes as input a screenshot of the whole desktop and outputs a mouse action that it wants to do, depending on both the screen but also on a prompt that I give to this agent. So I can now input an expression that I want the agent to compute using this calculator. So let's say I type 10 plus 23. And then I take my hands off the keyboard and the agent does its work. So it's now moving the mouse autonomously and predicting the concrete mouse actions in sequence. So I can move this window around, I can put it in different sizes, etc. And it would still find the buttons, hopefully. Try the same example again, but in a new position. So this is just a proof of concept of such a model. And this model is only trained to perform this particular task of computing stuff on the calculator. So if you ask it something else, it just would have no idea and just click around randomly. But I think it shows some potential at least. So, and this is now only trained on demonstrations. So basically, demonstrations like if I want to compute this expression, I click on these buttons and you demonstrate that and it can learn from that and also generalize. So for those of you that work with machine learning, this looks very much like a language model. It's a transformer model. And with essentially the only difference is that instead of working on just tokens, it can also now take a screenshot as input and predicting concrete pixel actions. Well, both different types of clicks and different positions on the screen where it should interact. All right. So I'm not the only one thinking in these terms, and I would like to just show a few other examples of projects that are going in this direction that could be useful to know about. So one example is this company Hyperwrite that is developing a personal assistant, and I think this is based on the GPT-4 language model actually. But using this plugin to your browser, say if I go to google.com, I can trigger their little plugin here and I can make a request. So let's say find a recipe for cinnamon buns. So this now sets off the agent and it can now autonomously interact with my browser window, click on different UI elements, type into text box, etc. To execute on this task. So this was a pretty simple thing. It typed cinnamon buns in the Google search bar and it clicked on the first link essentially. And this works essentially by just using a language model. So the good thing about using the browser is that we can actually get a visual representation by using the HTML instead. So we can just grab the HTML, feed that to GPT-4 and ask it where it should click or what UI element it should interact with. And that seems to work quite well, but it can only do its work in the browser where we have that representation. So there is another company that's called Adept that's also working towards this. And even though their product can only operate in the browser, it's actually vision-based in the background. So let's say we go to google.com again, and we try Adept's plugin instead. I can now, so this is perhaps not as autonomous, but it's vision-based. So it's actually looking at the pixels on the screen rather than an HTML representation. And this can be useful if you, let's say, have a canvas that does not have a structured representation of, let's say, buttons and etc. So let's say I want to find directions from Slussen to Medborgarplatsen in Stockholm. Then I need to sort of, at this point, specify the actions by hand, but I'm sure they're working on making this step autonomous as well. So let's say I want to go to maps.google.com and I want to type in the search bar, I want to type Slussen to Medborgarplatsen, and I would like it to click the search button, and and let's say I would like to, well, let's say I actually want to know how long does it take to go from Slussen to Medborgarplatsen. So I think I need to go to the advanced editor to add this. But here I can also answer questions about the screen. Right. So if I try to run this now, let's see how that goes. So it's quite fast. It types Slussen to Medborgarplatsen in the search bar. All right. Finds the search button, and now let's see if we can find the time as well. Right, so it managed to read out 12:34 to 12:37 from here. So and this is all based on the pixels on the screen, essentially. And finally, as the last example, I also want to highlight a startup in Stockholm, actually, QA Tech, that's also working towards this, specifically targeting web developers and in particular QA testing. So you can also use an agent like this to perform autonomous QA testing. Let's say that you, before a new deployment, want to make sure that the login works or that the checkout works, etc. You don't necessarily need to do that manually, but you can now use an agent to perform that instead. I don't have a demo of their system, unfortunately, but it's quite similar to the previous examples. All right. So to wrap this up and summarize, I think UI-based agents will form the next generation of foundation models in the coming few years. And this will make automating at least simple routine digital work. The cost of this will dramatically drop. And I think this will also be plenty of opportunities for developers and consultants like yourselves to focus on improving and adapting such agents for business and organizations. So I think, like we've seen with language models, where we want to adapt these using, let's say, RAG techniques, etc., we will also want to adapt these agents to work in particular cases, in particular systems, etc. And that's essentially what I wanted to say. So yes, I hope you found this interesting. And if you want to reach out to me, here are my contact details. And let's see if there are some questions in the chat.
Yes, there is. Do you want me to read them for you, or do you want to browse through?
Please go ahead and read them.
Yeah. So one question is it possible to get an AI model to generate Word PDF files based on input a person gives via chat?
Yeah. Yeah, so that's a great question. And I haven't tried this using ChatGPT, but I would assume that ChatGPT can do this already out of the bat. And my guess is that it would use, so in ChatGPT, it can trigger, well, it can generate and execute code. So it would probably write some Python code to take whatever text that you give the chatbot and use some PDF Python library to write it to a PDF file that you can then download. So I think that's how current agents would do that. Of course, using a UI-based agent, it would maybe be a little bit more involved. You could imagine the agent opening up Word or whatever, copy-pasting the text, and then actually clicking and saving to PDF, just like we humans would.
Okay. Then I have another question. If we assume that an AI could take over work by using GUIs made for humans, wouldn't we quickly end up in a situation where we develop UIs for a machine to, is it interpret or interface?
Yeah.
Yeah. Meaning writing code for code to interface with code. What do you see in the future use cases being?
Yeah. So I think I personally I'm not an AI doomer. I don't believe in AI is taking over the world, etc. But I really believe AI will be used to sort of enhance human capabilities and act as co-pilots. So sharing the same interface, as I've argued, really allows that, I think. So there's benefit in having a shared interface for machines and humans. So I agree that this will likely affect how we develop UIs, but it will be important also, I think, for humans to sort of take over and co-work with AI. So it also needs to be user-friendly for humans.
Yeah, and then there's more comments, a lot of thumbs up and happy emojis about the talk. And adapt AI seems like a lot of work, but perhaps it doesn't matter if you're using this for screen scraping.
Yeah.
Not so much.
Yeah, so I think the one hurdle here is the privacy aspect, I think. So, I mean, we are very cautious with what data we send away in general to ChatGPT, let's say. And if we are to simply stream the full screen to some overseas company, many of us would be very cautious of that. We have a lot of personal information we display on our screens, etc., that we don't want to give away. So one that's one crucial aspect here, and I think also that's where open source solutions will be even more competitive, let's say, where you can actually self-host systems like this for mainly the privacy reasons.
Yeah, and there's also a line here: screen scraping, for example, accessing Instagram data is rather hard. Screen scraping must be used
Yeah.
in the same thread. And another question here: do you think our browsing will be more conversation based rather than clicking and scrolling?
Absolutely. So we will have products and devices that will allow us to do more and more over voice rather than doing all the low level actions ourselves. And I think it will come gradually. We will be able to instruct agents like this to do more and more of our sort of boring repetitive stuff. Let's say, I think time reporting it doesn't take many minutes, but it's still boring enough for me to postpone it and forget it. It would be nice if I could just tell my AI agent to do the time reporting for me. I was sick that day, but otherwise nothing, and do all the points and clicking. And I think there will be tools like this that allows everyone to train their agent to do whatever particular work they are doing in a very easy fashion.
Okay, great. Do we have any more questions? Please feel free to write right now, or you can always email Tobias afterwards if you have anything else you want to discuss. And if nothing else comes in, I would like to thank you so much for doing this webinar with us. And
super happy to be here and presenting. And as I said, feel free to reach out to me if you have other questions or thoughts in this direction. Happy to discuss also.
Great. Well then, thank you so much.
Thank you.